Okay, so I think most of us have been in that situation where you're using like a general purpose programming language.
Yeah.
And it works, but for that one specific problem, it's just, I don't know, it just feels clunky.
Yeah, you're right. It's kind of like you're using, I don't know, a Swiss Army knife to try to like build the house.
Right, exactly. Like you could, but it's not really the right tool for the job.
It gets the job done, but maybe there's a better way.
Exactly. So that's kind of what we're talking about today, right? We're talking about domain-specific languages, or
Hmm.
DSLs, I think is the cool kids call them. So for those of us who, maybe aren't knee-deep in code every day, what is it like at its core? What makes a DSL different from like Python or Java, those general purpose languages?
Yeah, so I think you're right. You hit the nail on the head when you said that the Swiss Army knife, it's a good tool for general purpose, things. But if you want to be very specific, you need a specific tool. And that's what DSLs are. They're really specific to a domain.
Okay.
So if you want to crunch financial data, you would use a DSL specifically for that. You wouldn't use necessarily Java or Python.
Okay, so it's like instead of like a one-size-fits-all approach, it's like you've got a language that's tailor-made for, like you said, crunching financial data or like designing some really intricate 3D graphics.
Exactly, exactly. And that's the beauty about DSLs. They're very, very specific, which allows them to be extremely efficient and user-friendly for that specific task.
Okay, so it seems like these DSLs, it's like they're the specialists of the programming world.
Hmm.
But is this a new thing, or is this something that's kind of been bubbling under the surface of, like, computer science for a while?
Yeah, so that's a really good question. And it's interesting because DSLs have been like around for a really long time. I mean, think about Fortran.
Fortran, okay.
That's like way back in the day.
Way back. I feel like I vaguely remember that from my computer science classes, and it seemed ancient even then.
Exactly, exactly. Fortran was designed to, take programmers away from that low-level assembly language and be able to do mathematical computations a lot easier. So looking back, Fortran was actually a DSL.
Wow. I never thought about it that way, but that
Yeah.
makes perfect sense. So this whole idea of like tailoring a language for a specific job, I mean, that goes way back to the beginning.
Exactly, exactly. And that's what's really cool about it is that computer scientists realized early on, hey, we need more specific tools. This is not a one-size-fits-all kind of field. And they actually developed things like Lex and Yak. Have you ever heard of those?
They ring a bell, but you're going to have to refresh my memory.
Yeah, yeah. So Lex and Yak are basically tools that allow you to build compilers and parsers.
Okay.
So what compiler does is it basically takes a language and translates it for the computer,
Got it.
parses it.
So it's like the language behind the language. Oh,
Exactly. Exactly. And the funny thing is that these tools were used to actually build DSLs.
oh wow. Very meta. It's like
Mhm.
the tools used to make even more specific tools.
Exactly. And it just shows that DSLs aren't just this like niche thing.
Right.
They're literally used everywhere because it's just about being more specific.
So we're not just talking about like some obscure academic project. These are used for real world applications.
Exactly. Yeah. So if you think about like financial modeling, you've got hardware description languages like Verilog,
Okay.
and then you even have stuff for like web development like HTML.
Wow. See, and that's stuff I use every day.
Yeah.
And I had no idea it was at its core a DSL.
Yeah, exactly. And then there's even music programming languages.
Wow. Okay, so the range is really broad.
Very broad, yeah. And it can be kind of a lot, but an easy way to kind of break it down is there's two different types of DSLs. External DSLs and internal DSLs.
Okay, so external versus internal DSLs. Break that down for me.
Yeah. So imagine external DSLs as their own language,
Okay,
completely independent.
got it.
So if you're going to go learn that language, it's like you're going to go learn, Spanish. You're going to go learn French.
Right.
It has its own syntax. It has its own parsing. It's completely separate. An example of that would be SQL. So when you want to talk to a database,
Right.
use SQL.
Gotcha.
That's a great example of an external DSL.
So if I'm like learning an external DSL, it really is almost like I'm learning a completely separate new programming language
Uh-huh.
just for that one specific purpose.
Exactly. Exactly. Now, on the other side of that coin, you have internal DSLs. Internal DSLs are a little bit different. What they do is they're more like a customization of a general purpose language.
Okay.
So imagine like you have Python,
Okay.
and then you want to do something very specific in Python. You're not going to create a whole new language for that.
Right.
You're just going to kind of customize Python to be able to do that.
So it's like taking an existing language like Python and you're kind of giving it a specialized toolkit to do a very specific thing within Python.
Exactly. You got it. And that's what's really cool about DSLs is you can have these two different flavors and they both provide a lot of value.
That's awesome. Okay, so you've got these two different flavors, these two different approaches, both trying to get that same goal of specialization. What are some real world concrete examples? Like what do these DSLs actually look like?
Yeah, that's a great question. So you actually probably interact with the DSL probably more than you think. Think about form-based DSLs. So form-based DSLs, it's basically like visual programming.
Okay, so less typing code and more like dragging and dropping and that kind of thing.
Exactly. So if you want to build a UI, like a very simple UI, you can basically just drag and drop, buttons,
Okay.
text.
So like those website builders where you don't have to know any code, you just drag and drop stuff and it magically makes a website.
Exactly. That's a form-based DSL in action.
Gotcha.
And what it's doing is it's taking that complexity of the code and it's abstracting it away. And it's making it very easy for users to use.
So it's like the difference between speaking a language and using a phrase book, I guess.
Exactly. And that's a good point because it allows people that wouldn't normally program to actually program.
Okay.
So it really empowers people that are not, hardcore programmers to be able to create and do stuff.
Very cool. So it's form-based DSLs. What about some other implementations?
Yeah, so another really cool example is block-based DSLs. You've probably seen this if you've ever worked with younger kids.
Okay.
So they want to learn programming. They don't really know how to program. A really good example of this is Scratch.
Okay. Like Scratch, where it's the colorful blocks and you connect them.
Exactly.
Yeah.
And it's literally drag and drop.
Yeah.
And these blocks represent, different concepts like looping, variables, all this stuff that's really important for programming.
Yeah.
But it kind of hides it.
Right. It makes it more accessible.
Exactly. It makes it more accessible. And it allows, younger kids to grasp these complex topics without having to actually type it out.
It's a lot more intuitive, right? You're kind of learning the logic. You're learning the backbone of it without having to worry too much about oh, I put a semicolon in the wrong place and that kind of thing.
Exactly. And it just shows the power of DSLs because now you're taking these complex topics and you're making them very easy to understand.
Love it. Okay, so we've got these really visual ones. We've got these ones that are, good for education. Give me something a little more niche with a really specific use case.
Okay, so let's get a little bit more technical then, right? Let's talk about reactive animation DSLs.
Okay.
So these are really cool, and they're used a lot in the animation industry. What they do is they describe animations in terms of time-varying functions and events instead of frame-by-frame instructions.
Okay, so instead of programming every single frame of the animation, it's more like you're programming how it changes over time?
Exactly. So it becomes more dynamic.
Okay, very cool.
And it can react to things a lot easier, like user input.
So it makes it more interactive.
Exactly. So that's where it's really powerful because if you think about video games, they need that.
Right. Okay, so simulations, video games, that kind of thing really benefit from these reactive animation DSLs.
Exactly. And that just shows the power of DSLs because now you can actually start making languages that actually describe that specific problem.
It's like you're giving programmers tools that perfectly match the way they think about a problem.
Exactly. Exactly. And it makes it a lot easier to develop for. Now, it's not all sunshine and rainbows. Obviously, there are some challenges.
So what are some of the challenges? What are some of the things that make DSLs difficult?
Yeah, so one of the biggest challenges is actually the design of it. Building a good DSL is really, really hard.
What makes it so tough?
You need to find this fine line between making the language very expressive.
Okay.
Because it needs to be able to solve that specific problem. But at the same time, you also want to make it very simple and very intuitive for the users to actually use.
So you want it to be sophisticated, but user-friendly. And finding that balance is really difficult.
Yes, exactly. And on top of that, because these are very, very specific, you actually need to have really, really good domain knowledge.
So you can't just be a good programmer. You need to be a good programmer who also understands the ins and outs of that very specific thing you're building for.
Exactly. You hit the nail on the head. And because of that, there's actually another challenge is tool support.
Okay.
So we have great tool support for Java, Python, all these general purpose languages.
Right.
But when it comes to DSLs, it's very limited.
Oh, interesting. So you're kind of trading off that robust tooling and support for that specialization.
Exactly. And that's something that, it's kind of the trade-off that you have. But another thing you have to think about is integration as well,
Okay.
because software doesn't live in a bubble.
Right. It's got to work with other stuff.
Exactly. You're going to have to work with other systems. You're going to have to work with other code bases
Right.
that might be written in different languages, right?
So it's like trying to fit a custom-made part into, like, a machine that was built for, like, standard components.
Exactly. You can do it, but it's tough.
Right. Yeah. Man, this is really interesting stuff. Like, I'm learning so much about a topic that I had no idea about before we started talking.
Yeah, it's a really interesting field, and there's a lot of potential for the future as well.
Speaking of the future, where do you see DSLs going? Like, what does the future hold for all this?
Yeah, so I think DSLs are actually gaining a lot of traction right now,
Really?
which is really interesting, yeah.
Why is that? Why are they becoming more popular?
I think it's just because of the need for more specific tools. We're dealing with more and more complex problems now, like we're talking about data science, AI, biotech,
Right.
and you need a very specific tool. You can't just use a general purpose language for that.
I guess it is like you wouldn't use a hammer to, like, tighten a screw.
Exactly, exactly. And you wouldn't use, like a screwdriver to hammer in a nail. It's the same thing with programming languages. You need the right tool for the job.
Right. Right. So you're saying that by using a DSL, it's not just, like, more efficient,
Mm.
but it also kind of changes the way you think about the problem because you've got a language that's really well suited to tackle that specific problem.
Exactly. And that's what's so powerful about it is because now you're not thinking about the intricacies of the language itself. You're thinking about the domain problem, and you're able to express that solution a lot easier.
It's like bridging that gap between, like, really, really in-depth knowledge about a very specific thing and then the power of computing. It kind of brings those two closer together.
Exactly. And that's what's really exciting about it is that now, people that wouldn't normally program can program now.
Yeah.
If they have that domain expertise, they can use DSLs.
Okay. So it's kind of like democratizing access to these tools in a way.
Exactly. Yeah,
Right.
exactly. So it's really, really cool. Now, that being said, does that mean that general purpose languages are dead?
Right. Are they going away?
No, I don't think so.
Okay.
I think general purpose languages still have their place, especially when you're talking about, like, I don't know, building a compiler. You're not going to use a DSL to build a compiler. You're going to use, like C++ or something.
Right. So it's more like each has their own strengths and weaknesses. It's about, again, choosing the right tool for the job.
Exactly. And a lot of times DSLs are actually built on top of general purpose languages.
Okay.
So they all kind of work together. It's kind of cool how that all comes together.
So the future of programming might not be just one language to rule them all, but more like this ecosystem of, like, you've got your general purpose and then you've got all these different flavors of DSLs all kind of like working together.
Exactly. Yeah. And I think that's the beauty about it is you have all these different tools in your tool belt that you can use to solve whatever problem you have.
Very cool. What about, like, some specific applications? Like, what are you most excited about in terms of, like, what DSLs could potentially do? What problem could they solve that maybe we haven't even thought about yet?
Yeah. So, I mean, I think the possibilities are pretty much endless. But one thing I think that's really interesting is, like, imagine, like, personalized medicine.
Yep.
Doctors could use a DSL to actually program, like, specific treatments
Wow.
based on their DNA.
That is really wild. Okay, so, like, very, very targeted medicine.
Exactly. Or you can even think about climate change. We could potentially build a DSL that can actually simulate different scenarios. Like, how do we prevent this from happening?
So using DSLs to model those really complex systems and hopefully come up with some solutions.
Exactly. Exactly. And those are just like two things, right? I mean, you can think about like virtual reality. You can think about even like art.
Yeah.
The possibilities are kind of endless.
It's really cool to think about how it could go so far beyond just, like, traditional programming, traditional software.
Right. Yeah, it's really cool.
Right.
We're no longer adapting to the computer. We're making the computer adapt to us.
That's a really interesting way to think about it. Instead of, us having to learn the language of computers, it's like we're teaching computers to speak our language.
Exactly. And it's all about making it easier for humans.
Okay.
Yeah.
This has been super, super cool. Thank you for kind of, walking me through all of this.
Yeah, of course.
Like I said, I really had no idea. But before we wrap up, I've got one more question for you.
Yeah, sure.
We talked a lot about, like, DSLs, like you're writing code, right?
Mm.
But we also touched on that visual programming a bit, like with the form-based and the block-based.
Mm-hmm.
Do you see that visual programming becoming a bigger part of this whole DSL thing as we move forward?
Oh, absolutely. I think, visual programming it's huge. And especially with DSLs, it just makes so much sense.
Yeah, yeah.
Because if you think about it, it lowers that barrier to entry, right?
Right.
Now you have people that don't traditionally program that can now program.
So it makes it more accessible to a wider range of people. It's like I don't know. It's like the difference between like writing sheet music by hand
Yeah.
and using like a program where you can drag and drop the notes.
Exactly.
Yeah.
Exactly. And that's the beauty about it, is that now you're taking those domain experts and you're giving them the ability to create these really cool solutions without having to, learn all of the intricacies of, programming languages.
So it's less about like semicolons and curly braces, and it's more about like how can we take these concepts and how can we visually represent them in a way that people can understand.
Exactly. Exactly. It's all about how do we get those domain experts to like express themselves? How do we get them to use their expertise in a way that they can actually build something?
Yeah. Okay, so it's like instead of handing them, a hammer and nails, it's like here are these building blocks that you can, easily connect and experiment with.
Exactly. I love that analogy because that's exactly what it is. And I think we're only going to see more and more visual programming in the future, especially with DSLs. I mean, it's possible that, in the future, all DSLs will be visual.
Wow. So like no more writing code, it's all just like kind of drag and drop.
Exactly. And that would be incredible, wouldn't it?
Yeah, that would be wild. So like imagine like building a simulation or like, I don't know, some sort of AI system
Yeah.
just by connecting these visual components.
Exactly. Exactly. It'd be incredible. Now, that being said, I don't think text-based DSLs are going away completely,
Okay.
because there's still a need to be very specific.
Right.
And a lot of times, you can't just express everything visually.
Yeah.
You still need that level of like granular control.
Right. So it's not necessarily about one replacing the other. It's kind of like both have their place and it's just about finding the right tool for that job.
Exactly. And I think we'll see a future where it's kind of like they both work in tandem, they both complement each other, and it just depends on what you're building.
Awesome. Well, hey, this has been fantastic. Like really, really appreciate you taking the time to break all of this down.
Of course.
I feel like I learned a ton. This whole world of DSLs is super interesting. I think you've convinced me that this isn't just like some niche little corner of programming. It's really like a fundamental shift in the way that we think about not just programming, but problem
Mhm.
solving in general.
Exactly. Yeah, you hit the nail on the head. It's all about how do we use computers to solve problems? And DSLs are a huge part of that.
Awesome. Well, for anyone listening who, you know, this sparked their interest, maybe they want to go out and design their own DSL, what advice would you give them?
I would say go for it. There's so many problems out there.
Right.
And if you can find a problem that you're really passionate about and you can build a tool that can help people solve that problem, then you're really onto something.
Love that. Find something you're passionate about and then figure out how to use technology to make it happen. Awesome. Well, hey, thank you again for taking the time. This has been a really, really great conversation.
Yeah, it's been a pleasure. I had a lot of fun. Thanks for having me.